Welcome to the engineering support by James, video number 8. Previous videos from 1 to 7 we covered the different types of beams like cantilever, simply supported beam, and beams with internal hinge, and how to solve them that we mentioned in those videos. But now we will start with the numerical problem. So let us start with the video. This is 3 plus 5 plus 3, the total 11 meter of span of this beam. Here we have a concentrated load of 10 kilonewton, which is acting at 45 degree. In the with respect to the vertical plane, there is a 10 kilonewton meter moment is acting at C. Then there is a triangular load of 10 kilonewton per meter, intensity at T, and at C its intensity is 0 kilonewton per meter. And another one is the UTL of 10 kilonewton per meter from D to B, which is acting at 3 meter span. So A support is the hinge support and B is the roller support. So A is having the unknown, that is horizontal reaction as well as vertical reaction, and B there will be only vertical reaction. So as you know that there are three equations must be satisfied of equilibrium, that is summation of forces in x1 direction should be equal to 0 and summation of moment should be equal to 0. So our positive sign convention is from left to right. I am considering positive for horizontal force. For vertical upward force we are considering positive, and clockwise moment we are considering as positive. So let's begin the problem with resolving the inclined force, that is 10 kilonewton. That is 10 kilonewton multiplied by cos 45, which is equal to 7.07. Then we will resolve the horizontal force from left to right, that is 10 multiplied by sine 45, and it will provide you the value of 7.07 kilonewton. So next is we will consider only these forces, that inclined force we are converted into the vertical and horizontal force. So let us start the problem that using the textbook method. So we will first consider the summation of forces in x direction should be equal to 0. So HA from left to right I have assumed as positive, so HA is positive. Then from 7.07 is also positive, then I equate it to 0. So after solving I'll get the answer as 7.07 negative. So HA should be from left to right, sorry, right to left. So its sign should be like this. So our diagram should be like this as per the revised as per the reactions. HA from right to left as negative. So let us start the vertical force, that is summation of moment at A we are considering positive. So minus 10 kilonewton anti-clockwise moment plus 10 kilonewton multiplied by 5 divided by 2 is the total load. Then we will multiply it with the lever arm, that is 3 meter plus 2/3 of 5 meter. This is the total lever arm. Then we will consider the UDL, that is 10 kilonewton per meter multiplied by this 3 is the total load. Then the lever arm will be 3 meter plus this 5 meter plus 3 divided by 2 meter. So then we have a vertical force, that is 7.07 kilonewton multiplied by this 3 is the total lever arm. And then we will consider RB, which is anti-clockwise, will produce negative moment, that is minus RB multiplied by this 3 plus 5 plus 3 meter. Then we will equate it to 0. So after solving this we will get the answer RA is equal to 41, RB is equal to 40.32 kilonewton. So next is using summation of forces to y direction to calculate RA. So RA positive minus 10 kilonewton per meter multiplied by 5 divided by 2 is the triangular total load. Then 10 multiplied by 3 is the total UDL load. And then vertical downward concentrated load as 7.07 kilonewton downward is positive. Okay. Then upward RB equal to 0. This is our equation, and we'll put the value of RB as 41.32, and after solving the equation we will get the answer as 20.75 kilonewton.